And we are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of every problem of lead code and geeks for geeks. So without wasting any time, let's get started. Today's problem is construct tree from in order and pre-order, which is marked as a medium level problem. Let's find out what we will be given into this problem and what we have to do. So we will be given two arrays. First one is in order and another one is pre-order. Okay, all right. And both are of integer types, and what we have to do, so basically these in order and pre-order are the traversals of a tree. Okay, so in order traversal, I think everyone, if you are at this point, you should know what is in order traversal and what is pre-order traversal, but if not, I will tell you, no issue with that. So these two are in order and pre-order traversal of a tree, and there is no tree as of now. Okay, and we have to construct the tree. We have to construct the tree based on this in order and pre-order. So basically it is reversed. So ideally what happened is that we are given a tree, and we have to return the in order and we have to return the pre-ordered traversals of that tree. Okay, so this is ideally what we have to do, but here the problem is exactly opposite. We are given in order traversal, we are given the pre-ordered traversal, and we have to construct this tree. We have to construct this tree and return the root. Okay, all right, so this is what we have to do. I think the problem statement will be very clear to you. Now let's quickly understand what is in order traversal and what is pre-order traversal. All right. So look, if you will see this tree, so basically this is what we are given in order and pre-order, and we have to construct this tree. Okay. So look, in order basically means first of all the left nodes, then the root node, and then the right node. So this is what we will be doing recursively. Okay. All right. Let's quickly see what if we are given. Let's suppose we are given this tree, and let's try to write the pre-order and in order traversal. Pre-order and in order. Okay, all right. So pre-order basically, if you can see here, root, then left, then right. So what is the root right now? Root is 0. So let's write 0. After that, left subtree. Okay, so this is my left subtree. Again here, what I will do, pre-order, root is basically 1. And after that, left and right. Okay, so then left subtree is this here. And in this only one node is there, 3. Let's write that. And after that, left, look, root is done, left is done. Now let's pick up right is 4, so I will include 4. Okay, all right. After that, what I will do, this whole left subtree is done, this whole left subtree is done. Now this root is also done, left subtree is done. Now this is a chance of right subtree. Okay, so right subtree again, pre-order, root is currently what, 2, so right 2. And after that, left side is null, so nothing in left. And after that, right, which is 5. So this is what is the pre-order traversal of this binary tree. And if you will see this, sorry, if you will see this, 0 1 3 4 2 5, this is what is the pre-order traversal. And similarly, in order traversal is left, then root, and then right. Okay, so left, if you will see, let me quickly delete all these things. Yeah, delete this as well. Okay, all right. So in order traversal is basically left, then root, and right. So in that, what I will do, first of all, I will traverse this, then this root, and then this right. Okay, so first of all, in this root, again I will do recursively left. So left of 1 is 3. Okay, so 3. And again for this 3, what I will do, left, then root, and then right. So left is null, then root is 3. And after that, right, right is again null, right is again null. So after that, I will move again to the upside. So here left is done. Now let's take the root is 1. And in the same way, this 4. Okay, 3 1 4. After that, this whole left subtree is done. And after left subtree, what we do, root, so root is 0. And after that, right subtree, again left is null here, so 2 comma 5. This is what is in order traversal. And I will request everyone, if you are a beginner and you don't know this, please practice many problems on that, then only this pre-order, in order, and there is one more post order, that will be clear to you. Okay, all right. So pre-order, in order, I think everything is clear now. So now let's quickly understand how are we going to approach this. Okay, all right, let me quickly delete this as well. I'm not in a hurry, and I just want to make this video descriptive so that everyone can understand what I want to say. Okay, let's delete this. So if you have seen pre-order and in order what I drew, so pre-order is basically what? Root, left, and then right. In order traversal is what? Left, then root, and then right. Okay, let me quickly check if I've written it correctly. Left, root, right. Okay, so this is root. So pre-order, if we will see, if we will traverse the pre-order, if we will traverse the pre-order one by one, we can know what is the next root, because first of all 0, so 0 is the root. After that, in the left part, 1 is the uh, node, and after that 3 is the root recursively. After that 4 is the node recursively, and after that 2 is the recursively, and after that 5 is the root recursively. So in this way, if we will go on with pre-order, we can find out. But how can we find out? How can we find out ki yaar 0, so 1 3 4 will be in the left side and 2 comma 5 will be on the right side? Because we only know, with pre-order we can only know the roots. So here in order comes into the picture. Here basically means left, root, and right. So first root, here root is the 0. So if I will try to search my 0 in order, that I can found here. So it means root is this. So before root, if you will see, what is this? Left. And what is this? Right. So here this will be the left subtree and this will be the right subtree. Again, look, now with this statement, what my root is, let's suppose at this 0, so I have constructed my root node. Okay, and in the left side I will have 314, but I still don't know at what place will be what will be. Okay, and in the right side it will be 2 comma 5. Okay, all right. After that, second node is this one. Okay, so my second root will be this one. Let's quickly make it. So 1. Okay. Now I will 1 is there. So I will try to search this one in my in order. Okay. Look, my limit for this is currently this only, because left subtree is this only. Again here I got 1. So again I will recursively call ki yaar 1. So 1 left side of 1 will be its left and right side of 1 will be its right, till this point, till this 0, because 0 is the index, 0 is the root node. Okay. So for 1, again 3 is in the left side and 4 is in the right side. Okay, all right. After that, look, 3. So 3 is done. I've constructed. 4 is also done. I've constructed. After that, I got 2. So when I will get 2, if you remember, this 3 1 4, which is the left subtree, is done, and now I only have the right subtree. So 2 and 2. Okay, 2 and 2. So 2 is the node. 2 is the node, first of all, because it is coming in my pre-order next. So 2 is this. But what will be in the left side of 2? I will first of all check this 2 in my in order. So 2 is this. On the left side, it does not have anything, because 0 is the center node, which is done. So on the 2, there is nothing on the left. So 2 dot left will be null. And similarly, on the right, I have 5. So this is 5. This is what the tree we have constructed, and it is very very easy. I think the problem approach which we are going to do, and with like what help I am going to use with in order and pre-order, will be very very clear to you now. Key, look, at any point I will have a iterator. I can use a, let's say, global variable for that pre-order, which is currently 0. Okay, very very cool. Now what I will do, I will simply check my pre-order, like current value, which is 0, in my in order. I will try to find it. So if you don't know, in pre-order and in order, all the values will be distinct, meaning there will be no duplicate elements. Okay, all right. So 0 I found here, the 0 I found here, it means all the elements on the left side of it will be its left subtree, and on the all the elements on the right side of it will be the right subtree. Okay, so in this way we are going to approach it. Let me quickly give you a quick explanation with the code as well. Let's say I do a dry run, simple dry run. How can I delete this lasso effect? Control Z was not working actually. Let's quickly delete all these things. Okay, and let's copy. Oh, there are too many examples. Let's take this again. Delete this. Let's increase its size to 20. and this. Okay, so now we will understand recursively how are we going to make it. Okay, so currently I have a global variable. Let's say its position, and which is currently 0. Position is currently 0. It is global because we are not passing it with every function to update. Okay, but if you are using C++, you can use global variable, and we can pass. We There is no need to use global variable in C++ because we can pass a variable with its address only. But in Java, we cannot pass any variable with reference. Okay, so that's why I'm using global variable. No issues in that. Pre-order, first of all, my position is 0. My current range is what? Starting from 0 and till 0 1 2 3 4 5, 0 to 5. Okay, all right. Pre-order, first of all, what I get? Position is 0, so make a node with position 0 of pre-order, which is 0. So 0 node is constructed. Okay, after that, what I will do? Search this 0 in my in order. Okay, I got this 0. Okay, so now if you will see the range 0 to 4, and in order, the 0 is currently at 0 1 2 3, third index. Okay, so now 0 to 2 will be in the left subtree, and 4 to 5 will be in the right subtree. 4 to 5 basically means from 4 index to 5 index. Okay, let's do that. So from 0, let's pass ki, yeah, look, I have a subtree with the range from 1 to 1 to 2, 0 to 2. Range basically means the indexes of this in order, 0 to 2. Okay, and now 0 to 2 is there in the left side, and position is also increased. So now position is 1. Okay, so look, and also let me write it here, 4 to 5. So this 4 to 5 is the index, 4 to 5. Okay, all right. So now again the next position is 1. Position is 1, so make a node with pre-order, or with pre-order 1, which is 1 as well. So let's make it 1. Okay, all right, this node is constructed with 1. Now what I will do, I will check this one in my in order. Okay, I got this one here. Okay, no issues. So uh, 1 is constructed, and after that again I will recursively call key at left side of 1 will be its left subtree. So look, now 1 is independent at this point, but 1 dot left will be basically it's 0 to 1. Okay, so again I will pass key at 0 to 0 index will be its left, and 2 to 2 index will be its right, because one index node is already created and one index node is already created, something like this. Okay, so now again 0 to 0, which means only one node is 0, which is constructed, and again what 3 so 0 to 0 is the indexes. Okay, now the next node is 3, so I will construct 3, and in this way 3 will be constructed, 4 will be constructed as well. So left subtree is done. After left subtree is done, I will simply pass this node to its parent. Same thing I will do for this 3 as well. Same thing I will do for this 4 as well. I will pass it to parent. Now 0 node was created, left subtree I got, so I will simply do this new node dot left is equal to left subtree, and after that 4 5 is the right subtree, which is this 2 5. Now position will be something like this. Position will be this, which is currently 4, which is 4. Okay, so now position is 4, so let's create a new node 4 with value 2. Okay, new node is created. This is not yet linked. Okay, this is not yet linked. Okay, so 2, and now in the left side of, I will try to get this 2 value in my in order, which is this. So look, 2, which is this. Now it is at 4 index, so all the elements on the left side of this 2, which will be what? Starting point is 4, and ending point will be again 4, which is my current, and 4 minus 3. So now 4 is the starting point, and ending point is 3, 4 3. So starting is greater than ending, it means nothing will be there, and I will simply do null. And on the right side 5 is there, so it will be 5. In this way we are going to code it. I think the a little bit idea of what approach which we are going to take will be clear to you. But now when I am going to write the code of it and I will explain it simultaneously again, this will become crystal clear to you. Okay, all right, so let's see the code section of it. But before that, if you have loved the explanation till this point, please subscribe the channel and like the video, because it will really motivate me. And like, I'm giving my full effort and I'm making the videos at midnight, so it's, I think you should subscribe, and you will subscribe. Okay, so like the video, comment down how was the explanation till that point, and let's see the coding section. Okay, so first thing first, what I will do, let's, if you remember, I told you to make a variable. So currently in Java my function is static, so I have to make a static variable. Let's suppose static int, and I will name it pose. Okay, all right. Coming in this build tree function, first of all I will initialize it with 0, and now I will simply call a function which will be, let's suppose, solve function, which we are going to do, and it will return me the new root node. It will return me the new root node, which I will simply return. Okay, in this solve function I'm going to pass few things. First one is this in order, second one is this pre-order, and after that third one is my starting index, which is 0, and my ending index is basically any length, any array length in order dot length. Very, very simple. Okay, all right. After that I will simply again make this function static, and it will be again returning node. Its name is solve, and here I'm going to get few things. First one is in order pre-order, and after that int starting and int. Okay, all right. So very, very simple till this point. First of all, base case condition for this solve will be ki if here I am out of the bound. So what is the out of bound? If my starting at any point is greater than what, array dot length, so which is, let's suppose, in order dot length, because if I'm going out of the bound for starting, which is not good. And similarly, one more thing, starting should not be greater than end as well, because if you remember, for this 2 I was having this 2 here, and in the left side my end will be decreased. So starting was 4, end was 3. Starting was 4, end was 3, which means there is no elements inside it. So at that point I will simply return null. Okay, all right, which means there is no node for this. Okay, all right. After that, what I will do, I will simply make a root node, present root node, which will be equal to new node. I will use this constructor, and I will pass the value is what, if you remember, pre-order and position value. Okay, so simply do pre-order with position value. Okay, all right. And after that what I'm going to do, if you remember again, guys, very, very carefully, I told you to search for pre-order position in order array. Then only I can know the boundary of what will be in the left side of this root and what will be in the right side of this node. Okay, so let's quickly try this. So let's use for int I is equal to 0. I is not equal to 0, I is equal to starting, I is less than equal to end, I plus plus, and if at any point my pre-order pose is equal to in order of I, in order of this I have got the index. So now I can divide, basically make a division. So for that I will store that as well. So int div is equal to 0 for now. Okay, all right. And if pre-order is equal to this, I will simply do my dev. Why I use this dev, which means divide, div. Let's use div. Okay, so div is equal to I and break, which means now I will come out of this for loop, and now I got the indexes elements for its left and right. Okay, so what will be in the left will be something like starting is fixed, and uh, left, basically 2 points will be starting and end. Starting will be same and end will be div division -1. Okay, so what I'm going to do, I'm going to make this recursive. So first thing first, this position is used. Now I can write this position plus plus here as well, and now this root node dot left will be, I'm going to use recursively solve function again, and this time pass in order and pre-order as it is. And after that my starting will be same as well, and ending will be this division -1, because look, divisions division is equal to this. So basically meaning divisions root is done, made, divisions root is made here, and now on the left side I have to make, and right side. So left side basically means this division -1, and I will use root dot right. Guys, I hope you are with me till this point and it is clear. So now in that point ending will be same, which was earlier, but now my starting will be div +1, because look, div node is already made here. So now I have to just partition them into left and right, and after both left and right are done, I will simply return root. Okay. Okay, let's try to compile this, but before that I can see few errors. First one is I'm using this extra bracket here, and after that one more error is basically instead of passing in order dot length, I have to pass in order dot length minus 1, because in order dot length is out of bound. For this starting point is this 0 index and ending point is this 0 1 2 3 3 index, and I am passing 4 here, so I think it should give me error. And one more issue which I can found here is I'm incrementing position here. I have to do this after searching, because look, I'm again searching for this pre-order position, but here if I will increment this position, so it will be error. Why? Because look, currently my position is 0, which is at this 1 index. Okay, now I have made the root node with this position, with this value 1, and after that I was incrementing it here. I was incrementing it here, which is wrong, because now again I have to search this one in this in order. So to search it, we have to maintain the position. I will not increment it at this point, but after searching I can increment. So let's try to compile this now, and I hope it should get compiled easily. Yes, let's try to submit this. And meanwhile, if you have loved the explanation till this point, please subscribe the channel and like the video, because I'm giving my 100%, and it is getting compiled. You will get this code on my GitHub, and make sure to follow me on GitHub as well, fork the repo and start the repo. And yeah, that was it for today. I'm going to see you again tomorrow. Till then, keep on coding and bye, and subscribe the channel.